So which pair of equations generates graphs with the same vertex? So let's go over this, and we can go over a key concept here. So we're talking about a bunch of parabolas here, and to note first and foremost is that parabolas should have the same, in order to have two parabolas with the same vertex, they must have the same axis of symmetry. And the axis of symmetry is usually found by taking the, so let's first start with the equation of a parabola. So we get ax squared plus bx plus c is the general equation. So looking at answer choice A, for example, if we were to actually expand upon both equations here, so I'm going to multiply out them as they are. So we're going to get minus x squared plus 8x plus 16. And we're going to get y equals x squared plus 8x plus 16. And I'm just going to distribute the negative sign here. And the first thing that you'll notice between these two equations is that if we're finding the axis of symmetry, we want to use the fact x equals b over 2a to find what x value the actual the axis of symmetry is at. So in this case, our b value would be the value next to x. So for the first equation, our b value is negative 8, while in our second equation, our b value is 8. Right? So plugging in a as well, we're going to get that negative 8 over negative 2. We're going to get 8 over 2, and we find that they're both at 4. So that in itself would be, okay, wait, sorry about that. A more simpler way to approach this, as I'm just realizing it, is seeing at what x values we get a minimum at. So scratch what I've said, and at the answer choice A, we see that both equations at x equals minus 4 and x equals 4 are the two values that make it go at a minimum. Now, actually seeing both of these equations here, we know that that because they have different values of vertices, so meaning where the equation is at a minimum or where the vertex is located, wherever y is equal to 0, we can automatically rule out answer choice A. Now answer choice B is compelling because if we look at both equations, so y equals minus 4x squared and y equals 4x squared, we see that at x equals 0, both equations have a vertex, mainly because they're both at either at their minimum with this equation or at their maximum with this equation. That is either their lowest or their highest point. And because both values or both equations also give the same result at the same x value, right? So if you evaluate this first equation at x equals 0, you will get 0. And if you evaluate the second equation at x equals 0, you also get 0. It means that both vertices are 0, 0. So we could kind of just stop right there because we found that both vertices here are 0, 0, meaning that they do share the same vertex. If we go through the other results, answer choice C you could see is wrong because this C value right here that we've discussed previously, so plus 4 and minus 4, are the offset for the parabola, meaning if it's a positive offset, the parabola will go higher by 4 in this case for the second equation, or that if the parabola has a negative 4 offset value for C, it's going to go 4 units lower. For that reason, their vertex can't be at the same place if all of their points are shifted. So for that reason, they can't share the same vertex, and the same reasoning goes here, twofold. Firstly, because of the offset, and second, because again, at the value of their vertices are different. So here, we get that the vertex has to be at 4, while here the minimum value is at 0, right? So for that reason, they can't share the same vertex, even though they both point in the same direction, because their A values are positive. So it has to be, coming back to this answer choice B, to be the correct answer. And as we can see, this in-depth explanation here, yeah, just going in to show how the vertices are the same and comparing all the equations, and find that B is the correct answer. So that is the correct solution.